All right, we are recording. Welcome to the September 24th, 2018 Kubernetes SIG Apps meeting. I'll go ahead and put the meeting minutes into chat here. You can scroll down to September 24th and see it there. I don't have any announcements that I'm aware of this week. Did anybody have any other announcements or anything to share up front? I'll take silence as no. All right. Then with that, we have a demo of Copper. Do we have somebody on to give the demo?
Yes, Cash here from Cloud66.
Perfect. Then the floor is yours, and you should be able to start screen sharing when you're ready.
Thank you. Thanks very much. So I'm just preparing the to make sure that I have all the websites that I need open. Okay, great. So just gonna share my screen. Okay, great. Can everybody see my? Can you see my?
I can see your screen. Yeah.
Great. Okay. So, thank you very much for the opportunity. My name is Cash from Cloud66, and today I wanted to share with you one of our open source projects that we sponsor and develop actively as part of our Cloud66 product suite that is aimed to simplify deployment of applications onto Kubernetes clusters. This project today is called Copper, and the main purpose of it is to make sure it acts as a configuration validator for Kubernetes. But in general, any, at this point, YAML file that is usually used for configuration of anything, as a matter of fact. So it's not necessarily limited to Kubernetes, but we've developed it for Kubernetes. The reason we did that was we wanted to give access to our developers internally to the full upstream vanilla API of Kubernetes without having it wrapped inside anything else. And we wanted to be able to ensure and enforce some best practices around both the file configuration itself, the way Kubernetes cluster works, as well as the file naming conventions and all that kind of things that we have around building a Kubernetes cluster. So with that, we developed a Copper. You can check it out on copper.sh. But what it is, it's a very simple command line tool that we've integrated it into our SaaS product as well. And what it does, it ensures certain things within a Kubernetes configuration file. So if you take this as a example deployment of Kubernetes configuration file, for example, this is a deployment that I'm deploying in MySQL 6.5 from Docker Hub onto a pod. I want to ensure certain things. So first thing I want to make sure that we always have a specific version. We don't leave it to latest because we all know that's not necessarily the best practice. And I also want to make sure that you can only bump up my developers while they can add things like this, for example, on MySQL or Redis or any other database that they want. They can only bump it up by a minor version, not a major version. For that, what I can do is I can create what we call a rule file or a COP file, which is a very simple DSL. It looks, if you're familiar with JavaScript, it pretty much looks very much like JavaScript, but it's obviously not JavaScript. But the most important thing about it is that it understands some of the primitives or paradigms or things that are specific to Kubernetes or specific to containers in this case. So if you look at this rule, this ensures that there is no image on my deployment that uses the latest tag. And the way it works is we have a fetch command that fetches the node that we want within the YAML file. And this uses XPath or equivalent JSON equivalent of JSON path equivalent of that. And it's fairly simple to kind of read. So it goes after spec and then template and then spec again here, containers, and then .image, which collects and returns an array of all values under this. So if you have a pod with sidecars or multiple containers, it will return all of them. The next thing that you see here is an as image, which basically converts this, what we get, as an image. So you can see here and see an example of how this DSL understands paradigms within the container world. For example, this is an image reference, which would then mean implicitly that if you miss out this part, it knows that this is latest. And also you can break it up into pick the tag part, which then it will know it's that. And if you don't have it, it will return latest. And it makes sure with a string comparison, it doesn't have latest. So by doing that, you will kind of see how you can write these rules and enforce them upon your configuration files to make sure things are running on the way that you want the best practices for you to be. I'm just going to run through, show you a couple of more examples, and then jump into a quick demo of the CLI itself. So this example we saw, which is the one that ensures, and there are two different keywords here. You can have ensure, you can have warn, which will return two different levels of invalidation or non-compliant with compliance with the rule. And this we've seen. The other one that I wanted to do, as I explained, is that I want to make sure that we don't bump up the version of MySQL with more than a major version. So again, here you can see I'm using the same fetch, but here I'm more specific about what image I want to get. If it's MySQL, then I'm reading it as a semantic version or semver, so it understands that concept, and it can also understand pessimistic, optimistic, all that, semantic versioning paradigms. So I can make sure that I don't see any MySQL being pushed into my cluster that is above a certain threshold. Now, these two examples apply within the YAML file, obviously. So they read the YAML file and inspect it and then return a value, whether it's passes or failed. You can have a rule file that has multiple of these. But this is an example of how you can make sure that your naming conventions, if you have any, within your organizations are complied with outside the Kubernetes configuration file. So for example, here, I just made up this rule as an example that if you are doing a deployment, as in a Kubernetes deployment concept, Kubernetes deployment resource, the file should be in a subfolder that's called deployments. And it should have a YML as an extension, not like a YAML, for example. So as you can see here, file name is a keyword, so it knows what file it's reading. If the extension has to be .yml, if it's a kind deployment, then I want the path for this end with deployments, which means that the file lives inside a deployment folder, and they will allow you to enforce some file structure things around that. Another example is about understanding IP addresses. So I want to make sure that my IP address for the load balancer that I have on, for example, on a service is within a specific range. Again, here you see that it understands the concept of a CIDR and a subnet within the networks, and it will use that. And these are the examples of other things that we've seen as best practices, and sometimes we enforce them internally within Cloud 66 as well, where you want to make sure that you have always a namespace, not the default, or you don't pick up anything from a public Docker repository, or for example, only pulling images from a private repository. So those are the simple, some of the examples. Now I'm just going to jump right into showing you how it would work in practice. Hopefully this is the right size. So Copper is a command line tool, as I said. It's very simple to use. Now, here I have some samples of the examples that I explained. So if you look at this, we also have syntax highlighting for Visual Studio Code. If you want, you can use a Docker bundle Copper bundle for Visual Studio, which will give you this highlighting. So this is about the latest image. I want to also make sure that any image that's is used, we also have within that deployment, we also have the Docker repository secrets included. So we can actually pull the images out. And again, I want to make sure that MySQL port is, for example, 33 or 6. These are like made up examples, obviously. And the way I use it is I do a Copper check with rules being deployment cop, which is this file. And this is my deployment, which is a very simple deployment. I have a deployment here with a namespace and a name. And then within that, I have 3 containers running alongside Ubuntu, MySQL, and PG, Postgres. Obviously, it's a made-up example. You wouldn't run all these 3 necessarily next to each other, but just as an example. And then I would say file, deployment, YAML. And here you see that it passes 2 of the tests and fails on 1. And as you can see, I have a failed status exit code as well, which I can use in my flow. So that's basically like how it works. Again, on other parts, you can have. This is just an example of complexity of things you can have. For example, extracting with the regex on a name of an image, or if you look at this example, which is specific to a service, and the reason that kind of we like this is that sometimes we have a case where we want to enforce having a sidecar, for example, in our deployment, and that would mean let's say, for example, you have this sidecar that enforces having authentication for a service, and while I want developers to actively and consciously add that sidecar to every deployment that they have without having some magic that injects that, for example, with a admission hook or some other way that magically injects that into certain clusters and not all clusters, and then we kind of don't know why the behaviors change between 2 different clusters and all those things that we are familiar with. We want developers to actively and consciously include a sidecar. We also want to protect ourselves against them potentially forgetting to do that. And the way we do it is by creating these rules with Copper that will check if the sidecar exists, for example, and also it checks if the ports are swapped in case of, for example, this sidecar that sits in front of a normal service and hijacks the traffic on a certain port and uses like a proxy the way Nginx, for example, does that. And those are the cases that we use for that. As I said, we have Copper integrated fully into Cloud 66 SkyCap, which is our deployment pipeline into Kubernetes as a product, and we sell it as a product. And there we generate what we call stencils of Kubernetes configuration files, or Helm charts in this case. We generate those and render them into YAML files that then can be applied and piped into kubectl. But before we do that, we run Copper on that as well as a forced step, where it acts something like fxcop, for example, if you're familiar with that, as in both in terms of the style and in terms of the file hierarchy and structure around that. So that's basically a very short demo of what it does. I think it's pretty clear how it works. Again, you can check it out on copper.sh and also on GitHub. And Copper is just it's a cool project. We think that everybody can benefit from it. If you have any questions, I would love to answer them. Otherwise, thank you very much for the opportunity.
Now, I'll start the questions off. You said this can be used with YAML files in general. It's not tightly coupled to Kubernetes files. Is that correct?
That's right. So the main 2 parts that collects data for Copper are, one is a fetch command, which is a JSON path. And I know it's YAML, but we read the YAML and we convert it into JSON internally, so you can then use JSON path, which makes it very simple to address any node. YAML path is the equivalent of XPath for YAML. Is very complicated. So we decided to go with JSON path. So that's the first part. So from that, you can imagine, you can assume that any YAML file, and for that matter, any JSON file, can be consumed and any node to be picked up. And the second part, input data for it, is the file name itself, which would allow you to write rules about the file structure and the conventions that you have around outside of the content of the YAML file. And those are the 2 input points, and all the checks. I mean, there is a if I show you the kind of the DSL part of this, it's got a fair amount of things around syntax and conditions and ranges, and things are very specific, very generic in terms of how to how to write rules for anything. So, but there's also some parts that are specific to, you would say, containers in specific in that part. So if you can think of this like, gsub and count and split and things are like normal, and you have data types like arrays and other things. But then you get to parts that might be specific to, for example, containers, where you have pick the tag of an image, or when it's about IP addresses, things like that, which are not necessarily about containers or Kubernetes, but you can imagine that you can then use them more specifically for configuration files.
Okay, thank you. I do have a second quick follow-up question. You said, so we talked a lot about YAML files here, and we tend to do that a lot in Kubernetes, but you can do JSON files. If it ends in .json, does it know that it's a JSON file instead and just treat it that way and not do any conversions?
Not at this point, no. So the reason I mentioned JSON is because internally everything is turned into a JSON data structure, and then the rules are applied onto the JSON. It's only a matter of allowing JSON files being loaded, and then everything else will follow from there. At this point, we don't have that part that just loads it automatically, detects the file type, but adding it would be a very quick way, because everything from one side is generically converted into JSON, and therefore you have pretty much the rest of it unchanged.
Thank you. This looks great. Did anybody else have questions or anything they wanted to talk about with us?
Yeah, I had a quick question. Something occurred to me, just in part because this is a use case I was looking at last week. So this is really interesting for validating the spec side of things in Kubernetes. I've been interested lately in validating the status side of resources. So for example, you create a custom resource and wait for an operator or controller to do something, and you want to be able to make some kind of end-to-end test that'll validate that the right stuff you expected to happen did actually happen in the cluster. And it involves the same kinds of problems of querying for and reaching into objects but into the status, of course, instead of the spec, to then validate those things in the same kind of ways you're validating things here. Do you see that Copper might be useful in any way in that kind of use case?
Absolutely, that's a great example of how Copper can be used. So, as I said, we developed this as a way of ensuring that we give access to our developers to the full vanilla upstream, unadulterated API of Kubernetes, letting them do whatever they want to do, and Google, Stack Overflow, find issues and find the solutions to the problems they have without having to wrap it inside of another API just to make sure they do the right thing, quote unquote, but doesn't necessarily limit this. So and it's very easy to adopt a kind of that strategy from post deployment, where you can have a kube control describe or inspect that, out pops the YAML, and then you pipe it into Copper to get anything. And then also, as well as that, not only the specs, that YAML files for the specs, and as you mentioned, the post inspection of the post-release or post-rollout inspection of the artifacts that are now running, or resources that are running now in Kubernetes, but it could also be applied to other things that then generate a Kubernetes resource. For example, Helm charts can be validated with Copper as well. So, once you have a DSL that's fairly standard, as well as has a great way of kind of user-friendly way of being expanded into having specific domain functionality, then it's just a matter of how to use it and how to extend it. And we had to write Copper in a way that extending the DSL is very easy. The grammar is very easy to extend, and we wrote the whole thing deliberately for that purpose, so it can be expanded. We didn't want to end up with building another programming language. Essentially, it's just for the sake of it.
That's great. Are there any examples that you know of today of doing that kind of thing, like validating the outcome of a Helm chart?
So unfortunately, I don't have any examples right now, but one of the things that we actually do ourselves with Copper is that when we do make a deployment, we use Copper on both ends, and that's quite interesting. So one thing that we require every asset, every resource that's deployed to Kubernetes to have correct and conformed annotations for every resource. Whether, for example, if it's a deployment, it has to have certain annotations about where it's come from, what the Git ref is, and a unique deployment session. So that will then end up with having Copper as part of the flow. It will end up make sure that you have those annotations. Then on the other end, we have something that we call event relay, and that constantly checks the resources against another set of rules with Copper to find those resources based on the annotations that are now therefore definitely in there, and then check for other things to show up within those resources to make sure deployment's gone through. So it kind of closes the circle all the way around by ensuring that annotations are in there, so nobody will forget. Even if they forget, the deployment is just going to stop, it's not going to go through. And on the other end, we do a kube control, describe whatever we want to look for, -o YAML, and then pipe into Copper, and then we'll just apply other rules to make sure that everything just gone the right way, so we don't find any, for example, errors. Everything says successful, the volumes are mounted correctly, all that kind of other things that we have to check.
That's great. Thank you.
I have a question. So there's, I was curious if you had done any works. So I think this is great, by the way. One thing I was thinking of is when you have the running state of a cluster and that has, maybe the deployment definition or the image reference was done properly, but later someone patched it to be not proper. Have you given any thought in how you would integrate it with, other than just dumping, kubectl, get as YAML to some directory and then just running the scanning over that, but how that might fit into like a running instance or live kind of YAML or spec, if you will?
That's partly, well, not in depth, I have to say, from a Copper point of view, but that's practically what Cloud 6's SkyCap does in terms of, look, SkyCap is a SaaS service that connects to your Git repository from one end and then your Kubernetes cluster from the other end, and takes care of generation of configuration files, applying the Copper on it, and other things around, like another open source project we have called Habitus, which is about Docker workflow, build workflow, and all that sort of stuff, which is a live feedback. And the event relay that I mentioned earlier is part of that flow as well. But I can completely see what you mean when it's about having that. I think probably we can think about deploying it into some sort of controller that will then look into some resources. Any changes will then run against the Copper, or an operator that will pick up or inspect resources, inbound resources that are requests that are coming in, and then has it basically integrating Copper into Kubernetes itself, as opposed to having it on the boundaries of kube control.
Okay, thanks. That sounds good.
Yeah, I have one question. Is it like a Gazelle script, or like a validating? You said, right? It's validating the YAML files. Gazelle also doing same things, and it's like doing the same things, and it's taking some dependencies and libraries, like the same this Copper will do, or it will execute only whatever the YAML you mentioned.
I'm sorry, I think I probably didn't hear the first part of your question about the example. What's the kind of similar product that you mentioned?
Yeah, Gazelle script is that right? Gazelle.
Unfortunately, I have not seen that particular one. I have seen probably one more product that was, I think it was written, or project, open source project that was written, I think in Python, and it uses, maybe it was written in Go, and then it had a Python DSL in there. Maybe that's what you're referring to.
No, actually, yeah, I will ask this simple. Like, okay, how you will resolve the dependencies in your YAML if it is depend to other YAMLs, something other configurations?
So Copper at the moment doesn't deal with dependencies within the file. the other thing that it wouldn't be able to do is, so for example, dependencies when it comes to, I mean, YAML in general, obviously, there is no dependency unless you define your own protocol of dependency within that. Unless you're talking about the YAML protocol of like, two less thans and defaults that will bring different parts of YAML into one part, kind of the repeating part of YAML. It does support that, but it doesn't support any external dependency kind of language that you would define as a bespoke one. When it comes to specifically to Kubernetes configuration files, it very much assumes that everything that you need within that file being validated is within that file. So it doesn't understand how you would be able to kind of refer to another file in a standard way. And the other part that it wouldn't be able to do is if you have a raw block within your YAML file that is provided as part of, let's say, a configuration. So when you deploy, say, Prometheus with Kubernetes configuration file, you potentially have a raw piece of data within your configuration file, which is Prometheus configuration inside of it, and it's usually like a config map or some other blob that you get that is stored. Copper would not be able to inspect within those because that's not part of the YAML structure. It's just an arbitrary blob of text, and it doesn't do that either. So those are the two limitations that I would say at this point.
Oh, thank you very much.
All right. Thank you. Thank you for a great demo. We've been going at this discussion for quite a while now. So if there are additional comments or feedback, could you please add them or contact the Copper folks or paste them into chat, and we can continue discussing this along. I'm sure we could have a continued discussion, because when we come to validating these kinds of files, it's not that difficult to go into long conversations on them. Thank you very much for the demo.
No worries. Thank you very much. I'm just going to drop my email address and Copper website onto the chat. So if you want to reach out, please do from those ones. Thank you.
Fantastic. Thank you. And if we have time at the end, we can always circle back to this, and we very likely might today. So the topic that we have to discuss is, you'll see it in the agenda, learning end user needs. And it's one of those things we've kind of got to figure out a little bit more on. And I'll tell you what spurred this conversation on. I was, SIG architecture maybe a week ago. There was a conversation on conformance testing, and what are people trying to do with conformance testing? And there's the difference between vendors who are trying to meet conformance testing, yet we want the conformance testers to meet the needs of end users. And then who are the end users? Well, a whole bunch of them are app operators. Now, how do we actually know what they need? And we kind of got into a special little sidebar conversation on some of that. And somebody said, well, that's right up SIG Apps alley. Trying to figure out what these end users, whether they're app developers or more in particular, probably app operators, what are their needs? And then how do we know that, so that way we can make sure we build systems that try to meet those needs, right? And it's easy for us to think about it because a lot of the folks who work on Kubernetes are infrastructure developers and not necessarily app operators. And so how can we paint a picture for folks? And it was thrown back at me, hey, this is one of those things that would be really good for SIG Apps to chase down. And of course, we've done surveys. We do about one a year where we dig into app operators, app developers, and we've seen a lot of steady growth. And so we want to talk a little bit more about maybe how do we collect those needs, and then how can we document and share those and continue to iterate on them. And so I wanted to open it up because I've got lots of ideas, but I'm curious what you all think as far as what is it that, or ways we can collect these needs, and maybe the types of roles or responsibilities that we would be going after here. What do y'all think?
If I can just make a comment.
Yeah. That
is something that we've it's been on our radar as well, definitely, as a commercial entity who, we would like to build products, obviously, that are used by as many people as possible, and you kind of want to find a sweet spot of 80-20 when it comes to that. The best way that we found for ourselves was just being because we had to deploy our own products with Kubernetes ourselves, it's like this inception loop that's in there allows us to collect a lot of requirements that are ours ourselves. So we kind of follow the rule of, if it's good enough for us, if you want it to be good enough for the customers, it has to be good enough for us. And we have a fairly complex setup. But obviously, I cannot claim that that's a replicable thing that we can roll out to everyone, because not everybody is running like a SaaS infrastructure that's based on that. But we didn't have to run on Kubernetes, and that was a conscious decision from us. We were running very comfortably on EC2, on AWS, traditional, normal, whatever you want to call it. And we decided at one point that definitely we want to move everything to Kubernetes, just for the sake of having to go through the pain and the trouble that our users would go through, so we understand it firsthand, then we can solve it. And that helps us a lot. And the second part was opening up a very good beta program for our customers or for our users to have a good feedback channel around what they want to see around this. And then from there, we take it to roll out. So we kind of decided that we build out something that is about infrastructure. We give them the vanilla infrastructure they want, a Kubernetes cluster, but we don't leave them at that point. And we start observing exactly what they do. We stay in touch, we stay close as to what they do with the cluster that we built them. And then from there, we learn what the application layer is like, and then we build on top of that. I understand that comment might be very kind of specific in some areas, but I always think that the best way is just dogfooding everything to as much as you can.
Yeah, that's a real good idea, and I like to call it sipping our own champagne rather than eating our own dog food, because it sounds a little bit better, right? But it's that idea of eating your own dog food. One of the problems that we run into in the Kubernetes community, though, is a lot of folks are infrastructure developers. And so even the way they think about running applications in there and their use cases is different from an app developer. It's like the difference between application programming and systems programming. You might find a lot of corollaries in there, but you also find a lot of differences in the way you approach it, right? And so some of this is knowledge sharing. Like by eating your own dog food and following your customers, you've probably learned quite a fair amount about what do they need and how do they operate. But how do we now take ideas like this and convey it back to other parts of Kubernetes? So when we build stuff or when we evaluate things, we evaluate it from that end user's point of view rather than, it's easy to say, well, that's how I do things and that's normal. But if end users are doing stuff differently than I, in this case, and the I is other people in Kubernetes, and they're infrastructure developers, the way that they do things, I might be very, very different. And even the way they sip their own champagne might be different from a typical app developer, right? Like one of the conversations that I've had has to do with dependency management, right? And if you go in, you might use, GoDap, just update everything, or NPM update everything, right? To just give me all the latest updates. That's not an unusual workflow. And yet we've got folks around here who in the Kubernetes line will say, well, no, I'm going to import a dependency and I'm going to update it, and then I'm going to read the code that happened to change with that particular dependency when it comes in, so I make sure everything's kosher. And those are very, very different workflows and expectations. And so if that person expects everybody else to do it that way, then they might not be seeing the workflows and even the ways to improve it and the experience elements of it as well. And so part of this is maybe how can we collect some of this information, such as what you've collected over working at Cloud 66, and how do we kind of disseminate it to others and kind of have a shared understanding, and maybe multiple versions. Like there might be more than one way to be an app operator. How do we collect the different parts of that and communicate it, right? We do surveys every so often, and we give out those results, but what other things can we do? And how can we have it over the long term? Because part of this is very much information sharing in the community, both for the Kubernetes project and people who are trying to build stuff on top of Kubernetes. Because knowing your target audience is different than going off and coding a bunch of neat stuff to try to solve problems, right? There's kind of that two-part.
Absolutely.
So I know on Helm, and I'll share this. Ooh, share my screen. I'm now sharing the user profiles. On Helm, we actually created a number of user profiles. And these are essentially different roles. You'll see there's 10 of them. And we even list out the ones that were not in scope. I'll expand it down, which were the cluster operator, because in Helm, we're not so interested in the cluster operator. It's about app operations. And you see we've listed out who the different ones are. And this is just kind of where we've gone with roles. Should we do something like this with SIG apps? Because we talk about the roles of the application developer and application operator. Would it be worth taking those roles and maybe documenting them and then collecting different information sources that talk about those and linking people to them, or creating maybe a profile picture? Has anybody done that kind of stuff before?
Does it look like personas in that sense?
It's a little bit like personas. So the difference between maybe a role and a persona is a persona will describe an actual example person and their needs. And so you'll see a name and a face next to it, and it's kind of adding human characteristics to an actor, right? And where a profile kind of describes that category of people. They're used in slightly different ways, and normally you have to have a bit of knowledge in order to go create a persona in order to describe somebody. Maybe more than what you have with a profile and a better understanding, but they're similar.
I see. I think it's a very valuable thing to do, that's for sure. And I think the best people, in my opinion, that would do it, and this is based on us being next to consultancies and and consultancy companies next to them when it comes to like a KubeCon booth.
Yeah.
That's an interesting thing, because we see consultancies and IT consultants around Kubernetes consultants. Those are the ones who really know the requirements, because they're the closest to the end user and they see all different types of requirements. And we as product people, we are one layer removed from that. So when we are close to those guys and standing next to them on the booth, even, we get a lot of these kind of this information from there that, oh, we want this company uses it this way, and we go, oh, wow, that's an interesting way. So I think it might be a very good start to do this, and then get help from those folks to come in and chip in and kind of contribute their experience around what they actually see when they're so close to the end users. And everybody can then benefit from it from an app's point of view.
That makes sense. I also started to think about the fact that Kubernetes has an end user community. Is anybody familiar with this? Or I'm sorry, the CNCF has an end user community that covers all these things, cloud native. And they do surveys and they poke into some of these things. So it might be worth us going off and asking them about this and see what data they've got.
I know in the main Kubernetes documentation, it just says I'm an application developer or cluster operator. So it kind of touches on the user profiles already, but I'm not that close to if there's more somewhere that I'm not aware of.
That was put together by the documentation folks who are interested in this,
Mm-hmm.
but they are looking at application developers as also being application operators. And that's something we've tended to split apart here. Do you all tend to split those apart? Like, there are times where application developers also operate their stuff, but there's lots of times where the apps are thrown over the fence and somebody else operates them.
Right.
And I always look at like MariaDB or MySQL. Like, I never develop on those, but I operate them all the time, right?
Yeah, me totally. I totally separate them. Application developers, ones who's actively, working in Git and changing code and deploying those things, where an application operator may even be that one person who's labeled for that two pizza team to make sure the app's running that week or whatever. So they're on pager duty, which is a role they play, even though they are an app developer.
Yeah. Okay. Is anybody interested in helping me ferret out some of this stuff and documenting it? I'm guessing I probably won't be chasing some of this down until the second week of October. I'll email out to the list too, but I'd like to start getting some of this maybe documented and ferreted out, even if you just want to review it and that kind of thing. Let me know. Thank you.
Yeah, I was going to offer as well. That's Steve.
Steve, thank you. Yeah, in any capacity, I'll email out to the mailing list when that gets going, and I'll make sure I CC you, the two of you who volunteered, on it. Oh, Gary, thanks. Here. Can you send me your contact info? Here, you can send it to. I'll drop it into chat there. If you can send it over there, I'll make sure that I loop y'all in when I go do it. Thank you. And we can start getting some of this documented and shared. And I'm sure it'll be small initially, and we can start growing it and evolving it and building upon it. Are there any particular areas? So we're looking at the application operator and application distributor and probably creating profiles. Do we know of any data sets that are out there we can start with? Because there is the application survey, and then there is they did a survey over in the CNCF recently. There's those two sets of information. Are there any public profiles or data sets or maybe personas that different companies or folks have put together publicly and shared that anyone knows about?
I've not seen any.
Okay. Okay. Okay, and then all right. So there's two things we can go after there. Okay. I'm not familiar with anything. Many of the companies I've worked at have had private things, but I'm kind of looking for more public data that could help inform us. All right. So on this topic of trying to figure out end user needs, do we know of other ways we could go out and maybe learn it in addition to documenting it? Does anybody have ideas?
It might be a good start if we just start a mailing thread in the mailing list, and then we get like some time offline to think about this.
Sounds good. All right. Well, that's all I had on this topic. Did anybody else have anything else they wanted to add? Going once, going twice, going three times. All right. Then at this point, we still have about, is it 12, 14 minutes left? And we can have open discussion. Is there anything else folks wanted to talk about this week? Open floor, or we can have the time back. Going once, going twice, going three times. Folks, thank you for the conversation this week. And thanks again.
1 minute. Hello?
Yes.
Yeah, can you hear me? Actually, we are just writing for confirmation test for end-to-end test, okay? We are just writing. The script, what it is doing currently, right? It's reading the all test files into test files, okay? It's just writing wherever it is framework.it confirmation, some mentioning thing like some specific string. It's checking for some specific string, okay? Then it's writing it to one text file. Then it's testing only those files, okay? When we wrote the test cases in a for loop, okay, in a loop, it's failing to read that file, okay, and it's failing to update in that text files, that confirmation.txt, okay, confirmance.txt file, okay.
Yeah.
Hello.
So, yes, I can hear you. So there's a conformance that's having a problem. Is that it?
Yeah. Yes. Because it's missing the test where we are adding in a loop. Okay, for example, we are checking the part state, right? State life cycle state phase. We are testing it in one loop. instead of different test cases, we are writing in one loop because it's going to test for some examples. Okay, it's going to test the same thing. So the code block will be the same. Only the description is changing. It's running, it's not running. That description is changing. Okay, when we add it in a for loop and storing that description, mentioning the description dynamically, that time it's failing to write those test description in conformance.txt file.
Yeah. Okay. Is there an issue for this file already?
There is no issue.
Okay.
The script.
The reason that I asked that
can you hear me?
Yes, I can hear you.
Yeah, that walk.go, what we wrote, right? That one is written like only read the file. It's not taking, it's not executing and taking the data. Just it's reading the file, whatever it is. For that, the normal file without compiling the Go file, that for loops will not be different code. So it will take as a single line. It will check for that for loop and it will check for that the specific string conformance. Okay, if it is not there, then it is not taking those tests. So it was failing that thing.
Yes, and what I would ask
We can do one thing. We can write a different test cases instead of. Yeah.
Yeah, but the thing that I was going to say is that
instead of 5.
Can you hear me? Can you hear me?
Yeah, I can hear.
When it comes to the conformance,
yeah, I can hear.
The people who know the conformance test well were not able to make today's meeting. They're caught up in something else. And so I was going to ask if you could file an issue and share it with us, because we can pass it on to the people who know the conformance tests. They just happen to not be here today, and I can't speak well to them. You're breaking up on me. I'm sorry. Are you there?
Yeah. Thank you. I said thank you. I will do I will raise a bug.
And please, if you can, drop it into the Slack room.
I will raise the issue. Yeah, thank you.
And let us know, and then we can respond to it. But there are a few people who would like to take a look at that, who can speak to that really well, and they just happen to not be able to make it today.
Okay, sure. Yeah, thank you. I will do it.
Yeah. Do we have any other open conversation things?
Hi, my name is Sachin. I've been listening to these 6 for not more than 2-3 times. So forgive me if I'm not. I'm bringing up some issue which has been discussed before. I recently started working with operators, and one thing I find inadequate is these operators are basically just things in the wild. So when you use them, you don't really know if they work properly or not. And I was wondering if there is an effort under Kubernetes SIG to more put like standardization around these operators, where there is a bunch of conformance tests which tell you whether that operator is ready and it works as expected. Thank you.
That's a great question. I don't know of any conformance tests that are working there. So Kubernetes is trying to stay focused on the core of Kubernetes, and operators fall outside of that. So what you tend to find in the Kubernetes org or in Kubernetes, specifically Kubernetes is where they're trying to focus on compliance. Especially at an API and response level. You know, when you put something in, do you get what you expect? So that way distributions can do lots of different things in the back end, whether it's a distribution that's designed to work in AWS or in Google Cloud. Does it work the way people expect? Or maybe something that's shipped and you can use in many places. because there's a lot of different ways a cluster can be configured, and there are even elements in it that you can pull out and swap in with your own technology, or a vendor can. And so how do you make all of that conformant? And so they're focused on that more than anything else. And there's quite frankly, there's a lot to be desired in what needs to be done. A lot of areas don't have great conformance, and so that's what's being focused on. Operators happen outside of the Kubernetes project itself. Operators tend to happen when companies go create something. And so because it's not part of the Kubernetes project, they're not focusing on conformance of those. And so that's where things get a little bit harder. A lot of this is probably going to be more around people trying things just like you would a software library. Does it work or not? What kind of guarantees do you have in documentation? That's kind of where that falls into, kind of like the third-party software library space where you have to inspect it and figure out whether it works or not. I don't know of any effort right now to kind of standardize on conformance and try and help with that yet. But that is a good question, and it's probably an area that that could use some work. In fact, if a vendor wants to go after kind of helping with some of that, there might even be opportunities there, because I don't think the Kubernetes project itself is going to start chasing after third-party things. But conformant, there might be a company that's interested in doing that.
Yeah, that would be awesome. I think we can build something like the Helm chart have done, where there is an incubator project and there is a stable Helm chart. And then when you source from something from stable, you sort of know that it at least has gone through a few rounds and can work as expected.
Mm-hmm. No, that's a great idea, and we can investigate what else we can do to try to make some of that a little bit better on the testing front. Maybe some tools, or maybe some open source tools, or maybe even some apps to help test this. I think that would be a good idea. Yeah, and operators inside of Helm charts is something that's a good thing. It can be very much used.
Great, thank you.
All right, we got about 5 minutes. Did anybody have any other questions or topics of conversation? Going once, going twice, going 3 times. Thanks, everyone. You get about 4 minutes back. Have a wonderful week, and we will be back here next week. Thanks, everyone.
Thank you.
Bye.